This is 7.5, solving problems involving right triangles. To solve a problem in trigonometry, you always need a picture. Even if the question gives you a diagram, you should always draw a simple right angle triangle that shows the given requested information. Okay? The angle of depression and the angle of elevation. Okay, what are these two things? You're going to see this in word problems all the time. Okay? You have to understand that they are from the horizontal. Usually it's eye level. Okay, so angle of elevation is from the straight horizontal going up. Angle of depression, down. Okay, so this drawing is better than any words to describe it. That's why we don't have any words here. But here, this is angle of depression and angle of elevation. So from the horizontal, usually it's eye level. You have an angle of depression, and then from the elevation going up is the angle from the horizontal moving up. Okay? So you're going to hear this a lot. Angle of depression and angle of elevation. Basically, it's involving when you have a human person looking at something. Okay? Because as we look straight, that's our horizontal. As we look up, we get this angle to see an object. All right. So example 1. From a horizontal distance of 80 meters, the angle of elevation to the top of the flagpole is 18 degrees. So, doesn't talk about a person here, but we talks about angle of elevation, so we know we're going up from the ground, from the horizontal. We are going up 18 degrees, okay? And he's looking at the top of a flagpole. So here's my flagpole, there's my flag, here's my angle of elevation. So all of this with the right angle up to here should have been very easy to do, okay? Next it says calculate, from the horizontal, the distance is 80. It even gives us this. A lot of information and very easy drawing to draw. You know the way you get better at these? Anybody know? Jaden?
Homework.
Yeah, homework. That's right. That's the only way you get better. Practice. You got to practice doing these. There's no real... I can't teach how to solve word problems other than having you guys practice. I really can't. Because every question is unique. There's not really a set way to solve each problem. You have to have the experience of creating these drawings from the information that you're given. It's pretty much a set pattern. They repeat themselves. This is a very standard question. But you gotta practice. You gotta do your homework. Okay, so we have all this information about the triangle. And it wants the height of the flagpole. So we're going to label that X here. And then we're just going to choose the trigonomic ratio that makes sense with the information that we have. We're not going to choose anything with the hypotenuse here, right? Because the hypotenuse is in midair. We have no idea what it is. So, I mean, we're going to use either cos, tan, not sine, not cos, because they both involve the hypotenuse. We have to use tan. So it's going to be tan 18 is our opposite x over our adjacent 80. And then just solve for tan, we get 26 meters. Super simple. You should be solving these on your calculator. You can't do this with your calculator. If something's off, you have to tell me, because you might be in radians on your calculator, or you're not going to be able to get the right answer if you don't practice.
Sorry.
Yeah.
When do we use? I got confused there. I use division instead of multiplication. So how can we know?
Where?
I
Here?
accidentally subbed in the tan for x.
Subbed in the tan for x. You put tan over here?
Yeah.
I don't know. I don't know, like, other than just you doing it more to know, like, why would you put tan here? I don't even know.
I don't know. I'm going to solve for x. Oh.
This is the opposite side. Tan ratio is opposite over adjacent.
Oh.
TOA. Maybe run through that again. SOHCAHTOA, 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 SOHCAHTOA. Make a song. We used to do that as like a math project. Make a song about help you remember SOHCAHTOA. All right, example 2. from the top of a barn. Here's a beautiful looking barn. I think this was given to you guys, right? Yeah, no way they drove that. We have a 25 feet tall. So we have our triangle here. We're going to create it. We have this barn. There's 25 feet. That's what this triangle is here. 25 feet. You see a cat on the ground. So the cat, we label this vertices C. It's all the way on the ground down here. The angle of depression to the cat, so depression means going down, is 40 degrees. Now, it's super, super tempting, and many of you guys are going to make this mistake. Listen closely. Many of you are going to put 40 right here. This is the angle of depression down to the cat in our triangle. That is wrong. Okay? Why? Because the angle of depression is from the horizontal. I'll say it again. Angle of depression is from the horizontal. What that means is you got to create a horizontal line, this imaginary horizontal line at the top of the barn over here. And that angle from there is 40. Okay? Now it's not in the triangle, but we got all our nifty angle laws, right? We got something called Z pattern, right? As long as the ground and our imaginary horizontal line are parallel, which they are. Why? Because we've chosen it to be, right? We know they're parallel. We got this nifty Z pattern thing happening, so we know that the angle inside the triangle from the cat is 40. Any questions there? First tricky problem we've seen, maybe. They tried to trick you there with the angle of depression. But now we have 40, we have 25. We can pretty much, we have a right angle. We can do whatever we want. What does it want to know? How many feet to the nearest foot must the cat walk to reach the barn? So it wants to know this, right? X. Here's our cat. He's got to walk to the barn. It wants to know X. So we have X, we have 40, we have 25. We don't know anything about the hypotenuse, and we don't want to know anything about it. So again, we're going to use tan. We're going to say tan 40 is 25 over X. Tan 40 is 25 over X. Solve for X. Practice doing this, please. Everybody on your calculator, solve for X. Please do that. You're going to write X. Sorry, you're going to write 25 divided by tan 40. Everyone understand why it goes from here to here? If you don't understand that, ask me now. It's like we're very much approaching, this is too late to ask. Yeah.
So if the variable is on the bottom,
Yeah.
you divide it.
If the variables, we're just cross multiplying. That's all we're doing. So if it's on the top or the bottom, you cross multiply. Because there's a 1 here, Douglas, this 25 stays 25, and this x multiplies to tan x. So you would have had tan 40 here, but now we divide both by 40, so this comes down. You can basically just swap these. The tan x comes up here, and the tan comes down there. Why? Why? Well, because if we multiply both sides by x, these go away, x stays up here, and then if we multiply both by tan 40, then, sorry, divide both, because we want this tan to go, this goes away, and then this stays divided by 40, so they swap. You see? But it's a long way to say we're just cross multiplying and solving. Yeah.
I was wondering for a few days. You know how it says our homework on every single math video list?
Yep.
It's not the same as like the stuff.
I know.
So what do we go off of? Like what do we?
To be honest with you, I don't care. As long as you do one or the other, I don't care. Usually if it's listed on here, I'll say do this one. If it's not here, I'll say use the one in the course outline.
Like on,
But they overlap quite a bit, so it's not a big deal. As long as you're doing some homework, either that one from the course outline or the one down here. This one is better because it's more, I don't know if you looked at the course outline. Have you ever done homework from it? It's basically all the questions. This one is a little bit more hand-picked. So
like you, like,
I'd say it's a little shorter.
like some of them are like only do A and B because like C and D like B and
Yeah.
stuff like that.
Yeah. Is that on the course outline more like that?
No, the course outline is like let's say 127.
Yeah. So I'm assuming you want to do less, do this one. But I just want you to do some homework. Like right now there's like 3 people in this class that do homework. Like regularly they go home and they get their homework done and they upload it. You know, it's not a secret who they are. They say, hey, there's no drop folder available for the homework. What's going on? So I got to create it because they're the ones doing the homework. And the grade shows that. It's like not rocket science. Do your homework, you're gonna get a better grade. You want to pass the course, you got to do your homework. I mean, these bonuses and everything that I'm giving, you know, it's nice, but ultimately at the end of the day, this course comes down to doing your homework. I wouldn't have went as far with mathematics myself if I didn't do my homework, to be honest with you. Like, I went to U of T engineering, I had to know my math. I did my homework. I didn't do my homework in university because things got, you know, things get a little wild. You get a lot of freedom, and you know, there's anyone telling you to do your homework. Professors don't care. They do not care. And if you're smart enough to get by at university, then and you're in a decent program like engineering, then it's okay. It's good enough. You get a 53, no problem. You're going to second year university. You have 3 more years to figure it out and get grades where someone's going to hire you. So I didn't do my homework too much in university, but in high school I did it. Better believe I did it because I wanted to go to university. Yeah.
I like three units of like the homework thing, but like I have zeros on it anymore. I submitted it. Like, does that mean it's I submitted like a few days after like.
A few days?
Well, like.
How many
like,
days? What's a few?
Well, in unit 2, I wasn't even here for that month, so I did it.
What's a
after.
few days?
I don't know. I maybe submitted it like during what we're doing the next.
Not
week.
3 days though, right?
Not 3 days.
Like weeks?
Yeah,
Yeah, or maybe weeks. I'm not trying to pick on you. It's just because I don't go back there every time to like update. I can give you credit. I will give you credit. I'm nice like that. So, but that's why you don't have a mark right now. But that goes for anybody. You guys want to go home this weekend and go ham on your homework and hand in all your homework for chapter 1, chapter 2? I'm going to give you credit. I will. I will. I'm nice like that. I genuinely like all you guys. I like kids. That's why I'm a teacher. Some teachers, maybe they don't. I don't know. But I do. I want you guys to pass. I don't know why that's funny. Why is it funny?
No, it sounded a little bad.
What, that I like kids? I have 3 kids of my own. I'm not like a.
And we obviously.
If you're going down a dirty route, that's not what I mean, man. You know? No, I like, in all seriousness, like, all jokes aside, if you're gonna become a teacher, you should like kids, right? You should like to work with kids, right? No, some people don't. Some people don't have that like youngness in them, right? They don't have that immaturity for life. I have that. Like, I like to play with my younger kids, right? Like, I have a 6-year-old, I have an 8-year-old, I have a 10-year-old. Don't go there. Come on, man.
Sir, I'm actually sorry.
Don't go there. I'm talking about my family, guys.
TikTok links are mine.
You guys, it's brutal. Talking about my family here. Yeah.
Wait, are you gonna go to the first page and explain like when?
This page?
Yeah, I think that's wrong.
What am I explaining?
So I'm gonna explain like what means multiplication and what means division.
I don't understand this question. What are you talking about? When to use multiple? Where? To
You're
this?
explaining there, so like why did you divide?
Here? Okay.
If it's on the bottom.
Okay. Tan 40 equals 25. What was it? Tan 40 equals 25 over x, right? Okay, I use multiply or divide depending where the unknown variable is, right? I need to get this out of the denominator, right? I want it on the numerator, okay? Ethan, I want to solve for x, okay? So the easiest way to do this, listen up guys, the easiest way, in my brain, it's just this, x equals 25 over tan 40. They just switch spots. Okay, why? Because this is over 1 and it's cross multiply, right? So if I cross multiply like this, I get x tan 40 equals 25. That's what you get, right? And now if I divide both by tan 40, I get this, and then x equals 25 over tan 40. Right? That's to that. If it's on the numerator, x over 25, This is even easier.
Just move it to the left.
I just multiply both sides by 25. Why? Because these cancel out. I don't move it to the left. I just leave it where it is. That's it. Okay?
Do the same for sine or cos.
Yes, of course. Sine 35 equals 9 over, I don't know, 22. Now that is, sorry, I was going to say that's wrong because that's an exact ratio. But if I was doing sine theta, right? Now I wanted to get theta, I would just say theta is equal to, I'm dividing this by sine. Dividing this by sine. Both sides by sine. I get theta on one side, and then this, dividing by sine, is the same as multiplying by sine inverse. And that's the only button we have. We don't, we don't have a divide by sine nothing button. So we'll multiply by sine inverse, and then that will give you your degrees. Okay? You guys want to quickly know where all these numbers or ratios come from?
Actually, yeah.
Okay, I'm going to show you something. Now, I know 85% of you will never remember this, but if you do, you can look like a genius, a high-level genius to your friends. If you want to try this trick, okay? I'm trying not to waste a lot of time because I want to finish the lesson, okay? But this is what's called the unit circle, okay? This is going to take all of the mystery and magic out of these signs. That's a brutal circle, but I'm going to go with it. Now, the unit circle, we have our x and y, right? The unit circle, it's a really bad circle. I gotta start again, sorry. I can do better. Let's try. Better? Okay. Okay, better, right? You guys with me? This is 1, this is 1, this is -1, and this is -1. Okay, right? We know, this is 0.5, this is -0.5, this is 0.5, this is -0.5. Everybody's with me? This is a y and an x, right? Okay? You guys are good, right?
Yeah.
Okay, watch this. Gonna take a random angle. Let's go with this. Okay? And I'm gonna create a right angle triangle. Okay? Now actually this wasn't so random. I chose it right in the middle between 90, right? This is 90, so if I split it in half, that's 45. Right? You guys with me on that?
Yeah.
On this triangle? Okay. So if I do sine 45, okay? Don't tell me the answer. I can tell you. See, now this drawing is not great, but I think that's a little low on the angle. I think it looks more like this, a 45-degree angle. Now I can do this perfectly if I had like angles, right? But sine 45 is going to be around, not 0.5. It's the vertical distance, right? Because it's the opposite over the hypotenuse. The hypotenuse here is what on this unit circle? It's 1, right? Every triangle I make, the hypotenuse is 1. Why? Because I designed the circle that way. You guys understand that, right? The radius to the edge of the circle is 1, 1, 1, 1. Any angle I put here, like this,
Oh, yeah.
this radius here is going to be 1. Do you guys understand that? This hypotenuse, do you understand that? So then the sine value then of 45 on a unit circle is just the opposite side because it's over 1. So this is going to be around 0.7. Try it on your calculator. Right? I know that because I ran this back. Should be around 0.7. Yes? Is it?
Yeah, 0.7.
Now I seem like a genius. Watch this. If you do 90 degrees, right? So 90 degrees, I want to try to do a 90-degree angle. So I'm going to go like straight up here. Let's not do 90. Let's do like an 88-degree angle. So the way you would do that,
90, sir.
okay,
It's R.
this would be an 89. It would be like, okay? There's my unit circle. I drew it, sort of blew up over here, right? But here's my unit circle. Okay? Now, this angle here, right in there, is 89. It's very steep, right? Okay? Now, if I do sine again, it's going to be over the hypotenuse is 1. It's just going to be the opposite side. The opposite side is going to be really, really tall, right? It's going to be really close to 1. So sine 89's got to be like 0.99 or something, 0.98, right? Yes? Watch this. It even works with negatives, right? If I do a negative 45 over here, this angle here is negative 45. Actually, sorry. This would be negative 45 would be over here. Okay? You draw negative 45. Now, your opposite side here is not positive 0.7. It would be about negative 0.7, right? So, if you do sine negative 45, it should be about negative 0.7, right?
Sir,
Yeah.
is this like the graph that you're talking about everything?
Yeah.
But how would you use this in like a word?
You wouldn't. It's telling you where those ratios come from, what those numbers come from. So the way I would say that you can sound like a genius is, watch this. What is sine 0? Okay, don't use your calculator. Sine 0. So here's the 0 degree angle. It goes all the way to here. Okay. What?
I believe that's one.
Okay. I believe it's not 1. It's the vertical component, right? So think about, like, Janir, the angle is really, really low, right? Like this.
You said the center from the.
Right? This is sine 1 degree, right? Okay? What's the vertical component going to be of that angle? Sine 0 should be 0.
0.01.
Right? Sine 0 should be 0, right? Because the vertical component. What about cos 0? Cos is the adjacent now, so it's this length.
Oh yeah, one.
Cos 0 should be 1. Right? Is cos 0 1?
Yeah.
Yeah. How about cos 45? So now we're doing that same 45 degree angle, but we're not looking at the vertical component, we're looking at the horizontal component. It should be the same, right? It should be 0.7,
Yeah.
right? Okay, how about cos, I don't know, 225. Watch this. Like, I have no idea right now, right? I have no idea. We're gonna figure it out. 225. So we're gonna go 180. We know that's to 180, right? And now we have 225 minus 180 is 45, right? So we need to go 45 more. So this is gonna be 45. This angle here. So this here, this whole angle is 225. Okay? But I want to know what is the sine 225. It's going to be negative 0.7. Because it's this component, the vertical component of this angle. Is it right? Starting to understand? So now if I ask you, what is sine 0? The vertical component of this line? 0. What's sine 1? 1. What is sine 180? 0. What is sine 270? This angle. It's a vertical component. What would it be?
-1.
Negative 1. Because it's going down, right? What is cos 0? The horizontal component of this. 1. Cos 90? 0. Cos negative 1? Or sorry, cos, yes, let's do cos negative 1. It's going to be 0, right? Because it's the horizontal component of this. You guys sort of understand? When I was teaching grade 10 math, what I did is I made the kids do a unit circle on, you know, that chart paper? As big as they can, and they're only able to use that on the test as their calculator.
Oh, that's neat.
How they lose it?
Huh? They did good. They just had a ruler and they had a compass and they would measure the angle and then they would measure the distances. They didn't have to have a calculator. It was a SOHCAHTOA test with no calculator. Never been done before. The kids did fine. And if the kids, they could go to their friends and the friends would ask them an angle and they could visualize in their head that angle and they would do the unit circle in their head and they would know what the calculator would say. Right? You can impress your parents like that. If your parents give you, you know, what is sine 0.75? right? Or sorry, sine 75 degrees. You would, in your head, draw an angle of 75 degrees. You know that sine value is going to be around 0.85, something like that, 0.9. And if you drew this accurately enough and you measured these angles with a protractor, you would get precise decimal values. That's how this shit was figured out by these mathematicians. This is how they did it. This is where it comes from. And once they were able to develop this relationship between angles and ratios and right angle triangles, it made all of these word problems of like, you know, how far is the cat from the barn? Right? Not knowing that distance, right? But in their day it was like the tower from the water, or the enemies over the hill, how far away they are and how long will they take to get to us, became really useful information because they could just measure an angle from the horizontal. They would look down, they measured an angle. They wouldn't have to send troops out to measure the distance. They would know from angles. Really cool, exciting stuff. The unit circle. All right. Where were we? Cat in the barn. No, we're on example 3. I got 6 minutes. I can do it. I can do it. Adam and Brian are standing some distance apart from the same side of a building, 50 meters tall. So here it gets a little complicated now because we have 2 people, okay? It says, Adam stands, the angle of elevation at the top of the building is 30. Here's 30. And then it says where Brian stands, it's 60. What is the distance x between Adam and Brian? Now, this picture was given to you in this problem, correct? You guys have it? Easy. If they're giving you the picture, easy in a word problem. You don't even have to draw it. Even though they're trying to make it complicated, it's going to be easy. Watch. What's the distance x between Adam and Brian? They want to know this distance. So all we need to find out is we have these 2 triangles, right? We have 2 right angle triangles. Don't think of this as a triangle, but it's here and it's here, right? These are the 2 triangles. They're both right angle triangles. Right? Here and here. Okay? And all we need to do is find out this length and this length, right? If it'll be this length, y, minus this length, let's call it w. That's it. And then we'll get x. Okay? And we have 30 here, and we have 60 here. And we know how tall the tower is. It's 50 in both cases. Okay? So we want to know, this is y in the larger triangle. We want to know what y is. So we're just going to use our tan, because we have the 2 sides, not the hypotenuse. So you'd say tan 50, tan y. No. My bad. Tan 30 is equal to 50 over y. Y is equal to 50 over tan 30, which is what? What's the answer? For y? This one? 86.6. I shouldn't have called this x, right? Because this is x. This is w, sorry. And what's this one? What? Alan, come on, man. We only got 2 minutes here. Okay, 86.6, and then 28.87. Okay, so then we have y here, and we have w. So we're just doing y minus w is equal to x, right? You guys understand that, right? We take this big one minus that, we'll get x. So we say y is 86.6 minus 28.9 equals x. X is 57.7 meters. And then you would have a concluding sentence. Okay? I'm just going to talk about how we would solve this one. Okay? A lighthouse stands on a hill. Look, they drew it for you again. 100 meters above sea level. Sea level is where the water is, right? So we know it's already above that. So that's why we have 100 here. This is a very difficult drawing to draw, but they've done it for you. If ACD, I think D is this point here, right? Measures 60 degrees. ACD. So this is 60 degrees. And BCD is 30. BCD. So this is 30. Right? So then this angle in here has to be 30 because it obviously cuts in half. Okay? Find the height of the lighthouse. Okay? So we have to find H here, the height of the lighthouse. Okay? Where are our 90-degree triangles? We have to figure them out here. Okay? This is 100. Here's a right angle triangle. So we got 100, right? To the bottom of the lighthouse from the sea is 100. We know this is a right angle. This is 30 degrees. Okay? And then our other right triangle is going to go like this, where we have this big one, 60 degrees. And then we have 100. This is 100.
Sir, can you look at that?
Yeah, 100 plus H. Does that make sense? 100 plus H. Okay? With that information, we should be able to solve for H. Okay, and you're going to use tan ratios. So for, let's say, this unknown here, we'll say X. We'll say tan 30 degrees equals 100 over X. We'll solve for X. So we get this length. So that will be the same length as this length. So 100 divided by tan 30, 173.2. Okay, so 173.2. Now we have this, so we'll use tan again. Tan 60 is equal to 100 plus H over 173.2, and solve for H. That's it. Here, I'll finish it. If you wait, 173.2 equal to 100 plus H over tan 60. Okay, so I'm going to put this over H tan 60. Okay, so I get 173.2 minus 100 divided by tan 60 is equal to 115.5 is equal to H over tan 60. H is equal to times tan 60. 200 meters. Concluding sentence. Done. Watch the video.